that are assigned to financial institutions, for example. And when you use those, there's actually a differentiated user experience, for example, in the browser. So when I think about the credential scenario that you outlined, there's really kind of a life cycle that I think about when we worry about where's the risk to the credential, where's the risk to the user, how do we cue the user to what's happening with the credential, and then how do we enforce that it's flowing only to the the appropriate party. And then also, under the covers, how does the system ensure that that credential isn't being handled by code that doesn't need it, that doesn't need access to it? And in some cases, what we can do there is we can say that, well, the system, there's a system component that prompts for your credential, and then it may encrypt it with a key that's specific to that system boot, and then it flows through all these intermediate components until it reaches the end entity. So that's one actual way we deal with breaking kind of the references across components. The components still get to handle it, but what they're handling isn't actually usable. They're just acting as basically a dumb pipe. So that's another thing that we've looked at to reduce exposure to user credentials.
All right, so maybe let's try and just dig into it. So you talked lots of pieces that come into play there. So the first one you mentioned was going back to the kernel and saying, look, if you don't trust the kernel, someone could sniff your keystrokes, or presumably they could sniff the network access.
Mm-hmm.
So how do you protect against that?
So, well, a couple of things that we've done in Vista are really driving anonymity out of the kernel. So one of the big things that we've done for 64-bit x64 systems in Vista is we've said that all code that loads into the kernel has to be identified. A, so you have to be able to tell where the code came from. And then B, we'll actually verify at load time that the code hasn't been modified since it was signed by the original author of the code. So by doing that, what we've done is we've kind of driven out anonymity from the kernel. So now at least the user is in a position to identify what's running in the kernel. And then things like Windows Defender and other third-party security solutions, they have a better chance of being able to identify the good from the bad, if you will. So one situation that we have today with malicious software, for example, let's take a malicious keyboard driver. Pre-Vista, there were no expectations around that piece of software being digitally signed. So if a bad guy produced a bad keyboard driver and released it, there was no digital signature attached. And moreover, once it's out there, other people can modify that driver maybe in a subtle way such that it's no longer considered malicious by, for example, an antivirus product. So it's very easy to create permutations of a released driver, and there's no digital signing around that, so you can do that indefinitely. And to revoke, if you will, all those drivers, you're going to have to stay on top of every single permutation that's out there. So to stop that driver, you have to know about all of them, stay on top of it, which is kind of a reactive, endless game. With code signing in the picture, that there's actually it adds a nice level of indirection in that if I come to know that a particular signing key has been misused, and it's been used to sign malware, what I can do is I can, ask the question, should I revoke that key? Should all software signed by that key no longer be allowed to load, for example? So that's one thing we can do. And the other thing we can do, of course, is that it's much more efficient to maintain lists of, good publishers versus, publishers that have gone bad potentially or started bad. So that's one thing we can get there, is we can get a good inventory of the system. The user can tell where the software came from, and they can also tell if the software has been tampered with. Now, that's a step in the right direction, but it doesn't really tell us if a legitimate vendor has produced a driver that may have bugs in it. So you might have a driver that's out there that unbeknownst to the person that wrote it, it could be misused for some purpose like capturing keyboard keystrokes. Maybe I have a USB device, for example, that I plug in and it works fine and dandy under normal circumstances, but maybe there's a hole there that lets me exploit it. So digital signing doesn't help us at all with that type of situation. The case where we do have some visibility into that is really certification programs like WCL, where driver vendors submit their binaries to Microsoft. They run a bunch of tests, and from those tests we can sometimes tell if something is likely to go wrong there.
And WCL is the Windows hardware quality?
It's the quality labs, yeah. So that's really just a start. It doesn't solve the entire problem. It at least brings identification and integrity to the existing kernel mode code, but it doesn't say that, well, that code is good, it's bug-free, it can't be misused. That's right now something that we don't have a good general purpose solution for.
So I have two questions. A, why only 64-bit? I don't see why there's a memory requirement for patch guard. And second, what's all the noise that's going on about this? I mean, what does it mean to me as a software vendor that I now have to have my drivers signed in order to run in Windows? And what does it also mean for runtime kernel code? Like if I want to run some code in kernel at runtime from my application, what does that mean to me?
Yeah, so actually I'll address...
two questions.
Yeah, well actually I'll address the 64-bit question with two pieces of tech. I'll address two pieces of technology because there's really patch guard and there's the driver signing work. So the driver signing work is actually new for Vista.
Okay.
Pre-Vista we never had a requirement around digitally signing code for kernel space. It was recommended but not enforced. The only place where you saw that really surface pre-Vista was the plug-and-play install dialog, which ironically, you go out to Best Buy and buy a new printer, you read the manual and it has a photograph of the unsigned driver dialog and it tells the user just to click OK. So that's really the only place where you saw code signing surface for drivers pre-Vista. So for Vista we've just said that it's mandatory.
Okay.
So, and that's enforced at load time.
And that's x64 and 32-bit?
No, so that's x64 only.
Okay.
And the reason for that is really around application compatibility. So as I mentioned, a lot of legitimate software included drivers that were not digitally signed and in fact instructed users just click through the bad dialog box. And we took a look at the data. So the OCA, the online crash analysis team here at Microsoft, looks at kernel crashes on a daily basis. So they have a lot of data on what drivers are out there, and there are hundreds of thousands roughly of unsigned 32-bit drivers out there. So for us to turn on that option on 32-bit would probably be pretty catastrophic. Most of the driver software out there would stop working. So we said, well, 64-bit, x64 is new. There were roughly, when we looked at the data for XP 64-bit edition and Windows 2003 Server x64, we looked at that data and there were roughly 1,000 drivers out there, and the majority of those drivers were digitally signed already. Many of them were provided in box, or many of them the companies were working very closely with WCL, for example. A lot of the machines were server class machines where there's a higher expectation around driver quality. So we didn't really have that application compatibility burden to worry about on 64-bit. So we said this is a good time to do it. If we didn't do this in Vista, we would probably be having the same conversation that we had with 32-bit down the road, and that as well. There are thousands and thousands and thousands of drivers that are unsigned out there. We can't do anything. So
you have to, for 64-bit, you have to rewrite your driver anyways, because the 32-bit driver won't work on 64-bit. So
Yeah.
If you have to rewrite it, you may as well.
Yeah, I would say you probably don't need to rewrite it per se.